It says 130 milliliters of two different liquids are poured through a funnel with a narrow exit tube, and the time for all of the liquid to flow through is recorded, and then give some results. So for trial 1, liquid X is 1.8 seconds, liquid Y is 0.86 seconds. It finally says what is different about the two liquids X and Y, and we're looking for some different physical properties of the liquids. Well, this is measuring the speed of flow. The ability of a liquid to resist flow is called the viscosity. So this particular example is a measure of viscosity. For this question, I have several more examples, so I'm just going to move the sheet up and do the next one. It says 101 grams of two different liquids are poured into beakers. This is what the beakers look like after the liquids are poured into them. What is the difference between X and Y? Well, if we look at liquid X, there's a lot of it in the beaker. If we look at liquid Y, there's a lot less volume. But it's the same mass. So if you have the same mass and more volume, it's not very dense. If you have the same mass and a lot less volume, this is much more dense. So this might be water, and this might be mercury, for example. Mercury is an example of a very dense liquid. So here, the difference between these two things is the density. The next one may be a little bit different and something you've never seen before, but here are photographs taken of falling drops of two different liquids. The drops have identical volumes, and then it says what is the difference between liquid A and liquid B? Well, if they're both facing the same force, what you could see is liquid A is more like a ball, and liquid B is more spread out. Things that tend to form more of a ball have a higher surface tension than the things that get more spread out. Like, for example, if you put water on a freshly waxed car, you can see the water beads up. That's because water has a particularly high intermolecular force and therefore a particularly high surface tension. So this is asking about surface tension. The final example I have is 376 milliliters of two different liquids are poured into uncovered identical beakers and let stand for 10 minutes. So if we look at liquid X, the volume is roughly the same at time 0 and time 10 minutes. But if we look at liquid Y, at time 0 it had about the same as liquid X, but after some time it is evaporated. So, in chemistry, we say that liquid Y is more volatile than liquid X. It more readily goes into the gas phase. It evaporates quicker. For example, ethanol, the stuff you find in hand sanitizer, is more volatile than water. So when you put it on your hands dry quickly, and it also feels cold, but that's a different thing going on there. So what is different about the two liquids? Well, this property is not actually called volatility, although it kind of could be. What it's actually called is vapor pressure. So in this question, we very quickly went through 4 examples, and I don't give you a lot of detail on this, but in your book or in class, you get more details about what each of these things are and how they relate to intermolecular forces.